In this video, we're going to look at even and odd functions. We're going to start by looking at one even and one odd function, and then how to prove that the function was even or odd without having a graph. And then we're going to look at some examples of some functions and tell whether they're even, odd, or neither. So if f of negative x is equal to f of x for all x in the domain, the function is even and is symmetric with respect to the y-axis. And one of the more common even functions is f of x is equal to x squared. And the way we would prove this without having the graph, we can see it's symmetric with the y-axis when we have the graph. But we would plug negative x in for f of x. So here f of negative x is equal to negative x squared, which is equal to x squared, and x squared is equal to f of x. So since f of negative x was equal to f of x, we could say that this is an even function. And if f of negative x is equal to negative f of x for all x in the domain, the function is odd and is symmetric with respect to the origin. Now, one of the more common odd functions is x cubed. So again, we're going to plug negative x in, so f of negative x is equal to negative x cubed, which is equal to negative x cubed. And this is equal to negative f of x. So here we have an odd function. Now let's take a look at some functions and without their graphs, figure out if they're even, odd, or neither. In example 1, g of x is equal to x cubed plus x. So here if we plug negative x in, we have g of negative x is equal to negative x cubed plus negative x, which is equal to negative x cubed minus x, which you could also rewrite as negative x cubed plus x. So here we found that g of negative x is equal to negative g of x. So here we have an odd function. In the next example, we have m of x is equal to x to the fourth plus 3x squared. So here, m of negative x is equal to negative x to the fourth plus 3 times negative x squared, and this is equal to x to the fourth plus 3 times x squared, and this is equal to m of x. And when m of negative x is equal to m of x, we have an even function. In the last example, we have f of x is equal to x to the fifth plus 1. So here, f of negative x is equal to negative x to the fifth plus 1, and this is equal to negative x to the fifth plus 1. So here, f of negative x did not equal f of x, and f of negative x did not equal negative f of x, because here, if we had negative f of x, this would be equal to negative x to the fifth minus 1. And here we have negative x to the fifth plus 1. So this function is neither even or odd. And that's all for this video on even and odd functions.